All right, hello everyone. I think we'll go ahead and get started here. I have some slides on standard 3 for statistics, which is identifying, creating, and interpretive quantitative data displays. So the first type of tabular display for quantitative data is what's called a stem and leaf display. Each data point is split into what's called a leaf, typically the last digit in the data value, and the stem, the other remaining digits. Each data point with the same stem are grouped together in a single row in the stem and leaf display. So as you can see here, we have all the different stems. And each data point with the same first digit is categorized into one single row. So everything that begins with 120 would be in this row right here. Notice that there are two different 124s, and I record them twice. It's also helpful to make a key down below so I can see how to put each of the stem and leaf together to make the whole data point. The nice thing is I can see where a majority of the data points are clustered around. So this first display on the left talks about heart rates of students after doing 1 minute of jumping jacks. And we can see that there's, a bigger mound in the higher heart rate values around 130, 140. And then there's a smaller mound for heart rates in the 80s and 90s after doing 1 minute of jumping jacks. Over here on the right stem and leaf display, we have infant mortality rates in Western Africa. There is no key to how to put the stem and leaf together, but for this particular plot, we're talking about percentages. So for these mortality rates, what percent of infants died within these Western Africa countries? So I can see a large amount, around 11, 12, 13, 14%, and then a smaller cluster of data in the 8 and 9% infant mortality rates. The next type of data display for quantitative data is what's called a histogram. A histogram is very similar to a stem and leaf display, but rather than horizontal rows, now we're making vertical columns. So a histogram is a graphical display where quantitative data is grouped or distributed into equal ranges. These are called bins. Make sure that each bin is of equal value, otherwise it will distort your histogram. I count the frequency of data points that fall within each of these bins or ranges, and I plot that frequency along the y-axis. A good rule of thumb on how to divide your range into a set number of bins is to think of the number of bins necessary as the square root of the sample size of the data set. So the number of bins is equal to or approximated by the square root of n, where n is the size of the data set, the number of data points. So looking at this first histogram, we have body mass index for a sample of 101 adults, with the number of individuals plotted as the frequency on the y-axis. The bins are distributed evenly down below. So one bin would be from 18 to 19. The next bin would be from 19 to 20, and so on. So I can see that most of the adults in our sample had a body mass index of around 23 to 27, with smaller amounts less than or greater than that range. There were 21 or so as the most frequent BMI between 24 and 25. The histogram to the right talks about commute times for a sample of 1,000 commuters. These commute times are broken into different ranges or bins, as we can see down below here along the x-axis, anywhere between about 10 and 110. With the number of commuters that fell within those times plotted on the y-axis. So we can see that just over 200 commuters had a commute time of about 20 to 25 minutes. And most commute times were centered around the 18 to 40-minute range, with very few commute times taking longer than an hour. Think of a histogram very similar to a stem and leaf display. It's just running vertically as opposed to horizontally. Another type of histogram is what's called the relative frequency histogram, where I record the proportion of data points that falls within these ranges and plot that on the y-axis. So rather than the frequency, we have the relative frequency. These percentages indicate what proportion of the sample fell within each of these ranges. So two examples of relative frequency histograms below. This first one is the number of attempts required to pass the state teacher exam for 500 different students. So as you can see, 12% of the sample of the 500 students selected needed only one attempt. About 22% needed 2 attempts. About 27% needed 3 attempts. Very similar to a regular histogram, except now I'm recording the proportion that falls within these bins rather than the frequency that falls within these bins. It would still show the same sort of distribution. We can see that a majority of students needed between 2 and 4 attempts. Over here on the right, we have number of items sold at a garage sale. So 25% of the garage sales sold between 1 and 6 items. About 18.75% sold between 6 and 11 items, and so on. We can see that a majority, or I guess not a majority, but maybe two kind of clusters of data. A large proportion of garage sales sold between 1 and 10 items, and another cluster of garage sales sold between 20 and 30 items. Now that we've talked about different data displays for quantitative data, whether a stem and leaf or histogram display, we can analyze the shape of the overall distribution of our sample. One important thing to keep in mind is the number of modes. Does the histogram in the display have a single mound, a centered mound, or several different mounds of data? These humps or mounds are called the modes of the distribution. Mode means most common. So what is the most common outcome? What range has the highest frequency? So I can see in this first histogram, we have one mound. This would be an example of a unimodal distribution. Unimodal. Una meaning one mode. This middle histogram has 2 mounds for body length. This would be bimodal. Or you could also say multimodal. This third histogram on the right has no real mounds because each of these bins occurs with, approximately equal frequency. This would be an example of a uniform distribution. Every range has an equal frequency. Let's also talk about skewed distributions. A distribution can be left skewed or negatively skewed if there's a large cluster of data on the right with any outliers tailing off to the left of the histogram. So for this histogram down below, I have an example of a left skewed distribution. We're looking at return on stocks between 1971 and 2010. Most stocks gave a positive return with this mound of data here on the left side of our histogram, with the tail outliers giving a negative return here on the left. A left skewed distribution has the tail on the left side. So if I kind of draw over that, there would be an approximation of that distribution shown in black. Left skewed has the tail on the left with the mound of the data on the right. Left skewed or negatively skewed. Vice versa, you could also have a rightly skewed or positively skewed distribution. So this would be the exact opposite. In a right skewed distribution, the mound of data is on the left for the lower values, and there are outliers tailing off to the right for the higher values of the histogram. This histogram talks about Best Actress Award winners and their ages. We expect most Best Actress winners to have a fairly young age, but there are some outliers who win the award in their older ages. This data distribution would be positively skewed or a right skewed histogram. A symmetric distribution has one centered mound across the distribution, across the histogram. Examples of symmetric distributions would be heights, weights, ACT scores, IQ scores, those types of things. We have one centered mound or mode in the middle of the distribution. This is also called a normal distribution. The shape of a normal distribution is also called a bell curve. Anything kind of having this type of histogram, that type of distribution would be normally distributed. It is both symmetric and unimodal. We have one centered mound in the display. All right, let's look at a practice question here. For this example, this is just pulled off of your practice problems on Schoology. The question says to make a stem and leaf display and a histogram for the data described below. Confirm results using technology. I'm actually going to use technology first and then graph it by hand, just to kind of go ahead and get started. So the question reads, the Cornell Lab of Ornithology holds an annual Christmas bird count in which bird watchers at various locations around the country see how many different species of birds they can spot. Here are some of the counts recorded from sites in Texas during the 2015 event. So we have the data here. I've actually gone ahead and typed that data into a Google Sheet. To make life easier, let's sort the data numerically. Now it would appear that there are about 20 or so, 21 or so different data points. So I'm going to make a histogram with the square root of 20 different ranges. So that would be about 4 or 5. Any number of bins that would be less than 4 or greater than 5 would probably skew the distribution and not give you the most accurate picture of what type of display you would need to have. So now that we've got this data highlighted, we can go to Insert Chart with this picture here on the right of your Google Sheet. And here's our histogram. And as you can see, we have about 4 or 5 different bins. from 150 to 170, from 170 to 190, from 190 to 210, and 210 to 230. I can see that there were 12 different sites that had a bird count between 150 and 170. If I had a site that had exactly 170, which bin would I put it in? Would I put it in the left bin between 150 and 170, or the bin to the right between 170 and 190? The common convention is if you do have a data point that's equal to one of these cutoff values, you put it in the one to the left. So it would be 150 to 170, then greater than 170 up to and including 190, and so on. Now, if I play around with this a little bit, let me talk about how we can skew this distribution, skew this histogram. I want to have about 4 or 5 different bins, but I can play around with that a little bit. What if I change the bucket size to something different? Let's make it 50. Now I only have 2 different bins between 150 and 200, and 200 and 250. Don't really get a lot of information from this type of data display because the bins are not the appropriate size. I don't have enough of them. I can also make 10. That's not too bad, but I'm not really getting an accurate picture of what's really going on with the data. I made it 5. Google Sheets has an auto set to give you the most appropriate type of display. All right, let's go ahead and do the same thing by hand. Just kind of walk you through one of those as well. All right, so let's first do a stem and leaf display. For bird count. See, I'm going to do 15 down to 22 for all my different stems. I squeeze it down the bottom. For the 150s, this is why it's nice to have this already in order. I can see 2, 3, 3, 6, 7. Make this a different color. For the 160s, 0, 0, 2, 2s. 0, 0, 2, 2, 3. 0, 0, 2, 2, 3, 6, 7. For the 170s, 5, 7, 8. For the 180s, 1, 3, and 6. Nothing in the 190s. For the 200s, we have 2 6s. And then I have a 228. So the wire on the bottom. think of this as a stem and leaf display being a histogram rotated 90 degrees, running horizontally as opposed to vertically. We can also do a histogram going from so maybe say 150 to 250. Give yourself a little bit of leeway on top and bottom. We have about 20 data points, so the square root of 20 means maybe let's cut it into 4 different bins. So I have a total range of 100 from 150 up to 250. I'm going to cut that into 4 equal ranges or bins. So each bin needs to be 100 divided by 4 or 25. So see here, this would be 200, 225, and 175. Do your best to make the bins of equal length, otherwise it's going to greatly skew your display. All right. So between 150 and 175, how many data points are we talking about? It's going to be quite a few. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's do maybe 15, 10, and 5. So between 150 and 175, we had 13. Between 175 and 200. Notice they included the 175 in the lower bin. Between 175 and 200. Looks like we have 5. I'm going to make the next bar coming off of the bar previously. A histogram needs to be connected rather than a bar chart where I record a categorical data value. Between 200 and 225, I would have 2. And then between 225 and 250, there is only 1. So we can skew based off the histogram or the stem and leaf display that this would be a right skewed distribution. The majority of the data falls on the left for the lower amounts, with a few outliers here on the right. All right, that should wrap up standard 3. Have a good one.